surprisingly novel serendipity when you least expect it. Welcome to the next build in the Balloon Device Project. For first-time viewers, a little background. I'm building a device, a camera device, which will fly on a balloon by JP Aerospace up to about 100,000 feet in a little minicube. I'd like the device to take a picture every 15 seconds for about 2 hours. The serendipity was that once I built this device, I realized I had also built a stop motion camera. The duck movie at the beginning of this video showed the stop motion technique where I moved the duck a little bit between image captures. The features added in this build are battery power, an on-off switch, a button to start and stop the camera, a dip switch to control automatic mode or button mode, as well as the interval between pictures. You can find the details of this build as well as the Arduino code used to run the device on the URL that you see on the screen. Let's watch the device in action. Pressing the button starts the picture capture. While the LED in the center right is on, the picture is being taken and stored to the SD card. The dip switches are set to button mode and a 15-second interval. When the light goes off, there's an opportunity to press the button to stop the picture capture. 15 seconds is an adequate time to move your figures in a stop motion video, and for a 2-hour balloon flight, it will provide 480 pictures. Here's the opening of the Arduino IDE, where from the serial monitor, we can actually see the operation of the code as it runs the camera. The yellow bar at the top shows that the USB cable is not connected between the Nano and the Mac. Connecting the USB cable to the Nano provides power and starts the program. The code initializes the SD card, shows us the mode, and then waits for a button press. At the button press, the camera loop begins, and there's a 15-second delay before the camera takes its first picture. I'll speed this up a little bit to show the complete cycle of button on to button off operation. At the beginning of each line, we have a little text token to indicate the elapsed time as well as the current interval in operation. Notice the elapsed time on the take picture line. It goes from 24 to 39 to 54 to 69, showing that the take picture starts at the interval of 15 seconds. When the picture capture is done, I take the SD card out of the Nano socket and plug it into the Mac. To help with organization and record keeping, copy the files from the SD card onto a Macintosh folder where I annotate them with the name of the program that produced them and a timestamp. Scrolling up and down the file names is what made me realize that I'd created stop motion videos. So here's the wiring diagram for the new setup. I left off the wire traces for the common ports on the SD card and the camera, like the MISO, the MISO, and the SCK. I'll talk about all the pinouts when I discuss the balloon device pinout table. This table shows that dip switch 1 turns the battery power on and off, and that the button can start and stop the pictures when the code is in the button mode. I designed the table so the two most common modes would be all switches up for button mode and all switches down for automatic mode at a 15-second interval. Let's take a closer look at the pinout table. The pins on the SD card and the camera are the same as in previous builds. What's new here is the dip switches, the button, the power supply, and a discussion of the built-in LED. As I worked more with the breadboards and the wire connections, I found that these pinout tables were not near as confusing as they were to begin with. Look at the table and run a wire from here to there, matching colors when it seems useful. Buttons and switches are connected between a digital pin and ground. When the button is pressed or the dip switch is in the on position, the digital pin is pulled to the low state. In the setup of the code, It sets all digital pins to high so it can know when it's pulled to the low. Now I'm opening PyCharm, another interactive development environment, IDE, from a company called JetBrains. I like its style, and when I save code from PyCharm, it will automatically appear in the Arduino IDE, which I have open in another window. I will very quickly go through some features of the code. The code is available for download from the link you see on the screen. The button pins are defined as they were defined in the pinout table. We also see a listing that allows us to present the actual resolution that the camera is going to use. Here we read the dip switches and we look up the intervals and the modes via the dip switch settings. More setup to prepare the camera and the SD card. We also call the elapsed time function, which prints that readable token at the beginning of each line. Here we check that bit from the dip switch to determine if we're in automatic mode or in button mode. Here's the main loop, which either calls button mode or automatic mode. And you see that automatic mode is rather simple. It simply takes the picture, whereas button mode is much more complicated because it needs to listen for the button press. Here's an important technique. We like the pictures to be taken every 15 seconds. However, it takes time to take the picture and to save it to the SD card. So we set T0 to the elapsed millisecond time before we take the picture, and then we record the time elapsed after we take the picture. We can then subtract the elapsed time for the picture from the interval check so that we don't add the picture time to the interval. Here's the print elapsed time function, which allows us to print that nice token at the beginning of each line. A bit of a coding note. There are two print elapsed time functions. It's called an overlay. And what it allows you to do is to create a numeric print elapsed time and then use that same routine for a second print elapsed time when you'd like to have a title. The rest of the code has the take picture and the SD storage card logic. In a previous video, I talked about how much it took to get that to work. But now, thankfully, we can just continue to use it. From a technical coding point of view, this build went much smoother. What took some time this time was not a coding block, but my attempt to do a new design. I wanted to blink the LED, which would blink in a way that would let you know the number of the picture that it was taking. Well, it turned out that I tried to blink the internal button LED, but after quite some time, it didn't work. It just kept flashing or being dim or not behaving correctly. And it turns out that the built-in LED is also the indicator that the serial bus is working, as you can see in the pinout table. So you can't really use the LED in a controllable manner. That took quite some time to figure out. And it's an example of getting a piece of design that hangs you up rather than an actual engineering block. So thank you again for watching. Visit the website and there's more to come. We're going to solder this thing together and we hope to fly on a balloon someday.